Welcome back to another video of Math with Jonas. Today we are going to discuss the distributive property. You're going to see it all the time if you're taking any math classes. It's also practical to real life. And typically when I've worked with students and I see them make mistakes with the distributive property, it's because they don't have a full understanding of what it is. They were just shown it once. This is what it looks like. This is what you do. But as soon as any of that changes a little bit, or maybe they just forget, things fall apart. Now, that reminds me, and hopefully you'll never have to see this on video, but that reminds me of when I put together IKEA furniture. You know, you get all the equipment and you got all the materials. They give you a guide. It's got 40 steps, 1, 2, 3, 4, all the way to 40. They tell you exactly what to do. And if you've ever watched me put that together, by the end of it, you know, I'm putting a desk together and it's all done. I finish the last step and the whole desk is wobbly. And so, you know, I don't have that good understanding of building things and how things work. You know, I know there's some people out there that they take that instruction manual, they throw it out, and they're like, I'll just build this myself. And I'm just like, what? I'm just like, step 1, connect these 2 pieces. So my goal with this video is to first help you understand what is a distributive property. Like, what does that mean? And then we'll go through some examples that you would most likely see in your math class. And how to apply different things, like there's more than one x, there's negative signs, all that kind of stuff. But let's start today with what is the distributive property, and we're going to use soup as an example. So we're going to use soup as an example. I don't really make soup all that much, so please don't judge me too much if my made up ingredients are a little bit off in quantity. But let's say we have 4 cups. We're making a soup. We got 4 cups of broth. We got half a cup of onions. And we got half a cup of celery. And let's say we got 1/4 cup of peppers. And lastly, just to keep it simple, we'll say there's 1 cup of water. Okay, so we need all these things that I just wrote down. We need it all for our soup. And let's say this is for 2 people. So this recipe here is great for 2 people. All of this. Now, I don't know if any of you have friends like this, but you know, you're planning the dinner party, you're all ready to go, and then you got a couple of friends at that last minute to say, hey, you know what? Actually, we are going to show up. And so let's say in this example, you have 2 friends who at the last minute, they say, you know what, we're coming. So now all of a sudden you want to make the soup, but you need it for 4 people. You need it for 4 people. So we can't use the exact same quantities of ingredients because, well, we won't have enough soup for 4 people. And so we can see here that we're going to have twice as many people show up. And so what should we do with all the ingredients? And if your first thought was, well, we got to double all the ingredients, that's correct. So we want to double all the ingredients. And if we had 4 people, so we can multiply all these different ingredients and make them twice as big. So we would want 8 cups of broth. I'll shorthand 8 broth, but 8 cups of broth. If we had half a cup of onions, twice as much is 1 cup of onions. And that's going to be the same for the celery. Over here, we had 1/4 of a cup of peppers. So if we want to double that, we'll end up actually with 1/2 cup of peppers now. And lastly, we started with a cup of water, but we need to double that as well. So we'll end up with 2 cups of water. And that right there was actually an example of the distributive property. Not one you would likely see in your math class, but that's an example of the distributive property. And I know in this day and age, there are definitely websites where you can just click the drop-down menu and select how many people you want the recipe for, and it'll just calculate all the number stuff for you. All right, let's move on. One more thing about the distributive property. In this, it'll be a little bit quicker, and we're going to take a visual approach, and I'll also show that visual approach when we go over the actual math problems. But here, let's say you're building a house. So you're in the planning stages. Nothing's been built yet. You're in the planning stages, and I'm going to keep this simplistic. So you can go into a lot more detail with this, but I'm going to keep it simplistic. So let's say we had 2 rooms. One is 8 meters. The other is 10 meters. But you realize as you're planning for this house, you have a lot more space. You have a lot more space to actually build. So you're like, you know what? Why don't we make this a little bit bigger? Why don't we make this 3 times as big? So let's go ahead and separate this into the 2 different rooms. Okay. So you say, you know what? I want to make this house 3 times as big. So this first room is 8 meters, but we want to make it 3 times as big. So it's going to turn into 24 meters. And then the second room over here is 10 meters big, and we want to know what happens to that room when we make it 3 times as big. And we end up with a room that's 30 meters long. And so that again is another example of our distributive property. We wanted those numbers separate because they represent 2 different rooms. You could, I guess, in this example, make it 18 meters long. If you're curious about the total length of your mini house here, but if you're curious about the total length of it, yeah, you might add those together. But if you're making a blueprint, you want those rooms to be separate, and you want to know the dimensions of each room. You might make some changes down the road to them, so they're not set in stone. But that about does it for our, what is the distributive property? What is it? And it's taking multiple quantities and usually increasing by a multiple or a factor. So like in the soup, we made it twice as big. We had twice as many people showing up. In the house, we came up with a fictitious example of making it 3 times as big. You can also do the same thing with division, or say like you can take 2 quantities and cut them in half. So you can do that as well. All right, so let's take a look at this first example. It's our most basic example, and we've got some quantity x plus 5, and we want to make that 6 times as big. And so we'll take a look at this first with a visual approach and then with a non-visual approach. So kind of like I drew with those rooms, we're just going to make a little box over here. And I'm not going to draw the rooms to scale. I'm just going to split it down the middle here. But one room we've got x, and the other one we got positive 5, because it says plus 5. And we want to make it 6 times as big. So the area of this first room is going to be 6 times x, which I just write 6x. And the area of the second room is 6 times 5, and that's going to be 30. And so when we do 6 times the quantity of x plus 5, I'm just using what I got in these boxes. Positive 6x and positive 30 means plus 30. So it becomes 6x plus 30. If you're looking for a non-visual approach, we're going to take that 6 and we're going to multiply it by the first term in these parentheses. So we want to take that x and let me write a little time symbol. And we want to multiply it by 6. We want to make it 6 times as big. And so we get 6x. But remember, we have all of this stuff in parentheses. It's all getting 6 times bigger. We're basically, it's like a little cheat code where we can do some of that multiplying before we can simplify some of this multiplying before actually adding these terms. A little bit of a cheat code. But here we've got 5, and we want to make it 6 times bigger. So 6 times 5 gets us plus 30. All right, in this example, similar stuff, but we have subtraction. I'm just going to use the visual technique for this one, and I'll probably start going away from that for some of the other examples. So again, let's start with what's in our parentheses. We have 3x and minus 1. So let's draw our little box here. And our first room, we'll start with the first term, 3x. And then over here, we've got minus 1. Now, if we had another thing in parentheses, so if it said, for example, 3x minus 1 plus 2z, then we just need to add on another room, and we can have that one be 2z, for example. But here we only have 2, so we'll stick with our 2 rooms, and since we're making it 4 times as big, we're going to write a 4 out here. So let's look at the area of this first room. We've got 4 times 3x. And that's 12x. In the area of the second room, and pretend I know we're going to get a negative, so area and negative numbers, I just need you to pretend for a little bit. But when I multiply negatives, first thing I do is figure out the sign of my answer or product. So I've got a positive 4 times a negative 1, and a positive times a negative makes negative. Now I've got that out of the way, I don't even have to think about it. Now all I have to think about is what is 4 times 1? And you should get 4. And we can just write out what we see in the boxes. So 4 times the quantity of 3x minus 1 is just 12x minus 4. And if you're at the point in your math career where you are factoring, you can see that with 12x minus 4, you can factor out the 4 and we would get what we started with in the question. Move my big head down a little bit here. All right. Okay, so in this one, I'm going to go away from the visual approach. I'm going to do a non-visual approach with this example. And on the outside here, we have a negative number, negative 11. So we're going to take this 10 minus 0.5x. And even if we wanted to, we can't even subtract these two because we don't know what x is. We actually have to multiply 0.5 by x before we can do any sort of subtraction, but we have no idea what x is, so there's nothing we can do with that in the parentheses. But we're going to take this quantity and we're going to multiply it by negative 11. We're going to multiply each part of it by negative 11. So let's start with the first one. We have negative 11 times 10. So a negative times a positive makes a negative, so I just write out my negative sign. And then 11 times 10, any whole number times 10, you can add a 0 to the end of it. So it's negative 110 for 11, or negative 11 times 10. But we have a second quantity that's also getting multiplied by negative 11. We don't just stop at the first one. There's a lot of stuff going on in here. So let's go ahead and draw our second arrow. And we have negative 11 and minus, so keep in mind minus 1/2 x or 0.5x. So I have a negative times a negative. That means I'm going to end up with a positive. And we have 11 times, if you're using 1/2, you can write that as 11 over 2. But if we have 11 times 0.5, we can actually take 11, multiply it by 5 to get 55, but then divide that by 10, because this is actually 0.5, not 5. So we take 11 times 5 is 55, divided by 10, and we get 5 0.5. There was also a times x, so we can tack that on here as well. And so if we take this 10 minus 0.5x and we multiply it all, we multiply that subtraction problem by negative 11, we end up with this negative 110 plus 5.5x. A good habit, this is correct, but a good habit, especially if you're doing anything with graphing lines, is to write this in order with your variable term coming first. Some teachers do require this. So let's flip-flop these. We have positive 5.5x. So we can write 5.5x. And then we have negative 110. So we just write minus 110. So that's how you would flip-flop the order of those two. Whether or not that's required for you, it's definitely a good habit. Okay, in this example, not too wild here, but we got 2x on the outside, and we have an x on the inside. So we got some more than just one x in this expression. I'm going to bring back the visual approach for this one. So let's go ahead and make our little house. And in the parentheses, we have x plus 7. So that's going to dictate our rooms here. We have x and then positive 7. And what are we multiplying it by? Well, 2x. And we can still simplify this. We don't know what x is. We have no idea, but we can still simplify this. So here we have 2x times x, or 2 times x times x. And so that actually gets us 2x to the second power. Just like if, if this was 5 times 5, you could write that as 5 to the second power. And it's the same rule with x's. Over here we have 2x times 7. And 2 times 7 is 14 times x. So we can just put an x there. So 2x times 7, 14x. And since we're using this visual approach, we can just take what we wrote in our boxes and write it out. So we can simplify 2x times the quantity of x plus 7. That can become 2x squared plus 14x. All right, easy does it. We've got 2 more examples to go. In this one, we have 5x times the quantity of negative 6x squared minus 5. Again, let's go back to the visual approach. I'm a big fan of it for distributive property. I won't lie, I can do most of these just in my head automatically, but I really like the visual approach. Anyone that I've worked with, or when it gets real complicated and stuff, I find that it keeps it nice, neat, and organized. So if you're struggling at all with this, I highly recommend the visual approach. Let's start with what's inside our parentheses. So our first room is going to be negative 6x squared. And again, we're not drawing the rooms to scale, so don't worry about making sure your little house here is perfect. The next one we have is minus 5. So we got to write over here, minus 5. And what are we multiplying all that by? 5x. Okay. So in our first box, I notice I have a positive times a negative. So I know the product's going to be negative, so I'll just get that out of the way. Now I look at the numbers. 5 times 6, that's 30. And now let's look at the variables. We have an x here times an x squared. So that's x times x times x, or x cubed. Now we go to the second room. We have a minus 5 here times a 5x here. Again, a positive times a negative. Let's make that negative. And then we have 5x times 5, and that's going to be 25x. And again, if you're using this visual approach, we can just write it out. Negative 30x cubed minus 25x. And if you tried this without the visual approach, if you just did your arrows, you should have come up with the exact same expression that we did down here. All right, on to the last example. This one's kind of a gray area. I think of it like distributive property, but you're distributing subtraction. Maybe someone more technical than me might be able to comment below if it's actually distributive property. It's also very similar to when you're doing distributive property and you're multiplying the stuff inside the parentheses by -1. So very, very similar stuff. But, excuse me. But I see a lot of mistakes with this. I see a lot of students make mistakes with this. And that's why I want to highlight this example in particular. In this one, I am not going to use the visual approach. We're going to go a little bit differently with this. So just to read our expression, we have 8 minus the quantity of 2x minus 13. So what we're doing is we're not just subtracting 2x, we're subtracting 2x minus 13. So you can think of this subtraction distributing. We're subtracting that, and we're subtracting that. And if you're one step ahead of me, you might see a double negative coming. But let's start. So we have 8. And the first thing we're doing is we're subtracting 2x. So we write minus 2x. But we're also subtracting this minus 13. So we're subtracting minus 13. And there's that double negative I was just talking about. So let's go ahead and rewrite that without a double negative. That makes it a lot simpler. So minus minus, right? Where's my other hand? There it is. Minus minus becomes a plus. So we'll write this as 8 minus 2x plus 13. And you could stop there. I would clean this up further. You'll notice that 8 here and plus 13 here are like terms. So we can actually do 8 plus 13 and get 21. And then we still have this other term that we can't subtract quite yet. So we just write minus 2x. And again, if you want to build a good habit, or if your teacher requires it, where you need to write the variable term first. So notice right here, it's minus 2x and then positive 21. So if we flip-flop, we write minus 2x plus 21. And that about does it for the distributive property. Sure, you can have 3 or 4 terms in the parentheses. You can have more variables and things. But the actual property itself, knowing what the actual property is, you've seen it here. So yeah, you might have more stuff in your problem, but it doesn't get more complex. As always, if you like the video, go ahead and click that like button. If you like what I'm doing, go ahead and subscribe. And if you have any comments you want to leave, including ideas for a future topic or for a future video, leave it in the comments below. Thank you all for watching, and I'll see you on the next one.